does. No, it does not. Yes, it does work. Okay, welcome back to the Yocto live coding sessions in the second half of the year, of the wonderful year 2021. My name's Josef. I'm known as the Yocto Jester by now, and you can see there have a couple of things changed. Mainly, I have gotten myself a proper microphone. One problem you've probably noticed that my usual bumper slides are gone or have gone for this session. Yeah, there have been some troubles with my setup, my whole organization and whatever, but we'll get this sorted out for the next couple of sessions, hopefully real soon. Okay, so I'm back, and we will be talking about testing today. I promised to do ptest and test images. I will have to take this back a little. I will just cover ptest for today. Mainly because I think it's enough content for one session. Plus, the test image is a little bit hard to handle in the setup that I have prepared, and so I would rather like to just go around the ptest and what does this testing actually mean, instead of cramming into topics. I'd rather do a separate session on this if it actually should make sense somehow, because I think test image is more of interest to those who really do distribution test level testing, whereas ptest is more for application developer testing, and that's where most of you are probably spending their time. Okay, so hopefully this works now. A couple of you have probably witnessed that I was fighting my terminal setup. Okay, here we are. This is a rather generic build directory I have prepared. You can see it has a Pocky download and a build. The caches are all hot. I've had it running for a couple of times already. Okay, and so we want to get into a ptest. Ptest means a package test, and essentially it means that we are running a test suite that the package brings along on the resulting target. Now, this means a couple of things actually, because first, your package actually has to have a test suite. This is the first thing that we will look at. The second thing is that you have to actually bring that test suite into the build. Usually test suites are meant to be built and run outside of the actual resulting artifacts that you want to produce. Usually they are meant for the application developers to be run during refactoring. We're talking mostly about unit tests here. There are other approaches like integration and end-to-end or whatever, but that's not the topic of the session. We are talking about unit tests who are meant, or which are meant to be small and fast, so that in the optimal case they could be run right after every git commit, or even better, after each and every file save. That's a bit much, but that's the optimal case, and therefore we have to look at where those are and what they do, and then how to get them onto the target, because that's just, as I said, they're not meant to end up there actually. And third, we have to look at how they are kind of automatically run by the ptest infrastructure that Open Embedded and the Yocto project happily bring along for us. Okay, so any complaints about my sound or my looks? I know I could have shaved a little, but if nobody complains in the next 5 seconds, I'll assume everything is okay. You can read what I will be typing. To me, it looks good. The levels also look okay, and hopefully it's understandable. Okay, so here we go. We will be using a package that I have already used in another context. Another context, and I've beaten into shape a bit for this session. It is about here. Those who have been around with me for a couple of months will know it. It's the lib answer. Okay. Let me scroll down a bit. You can read it. I'm seeing it. Here it is. GitHub / the Yocto Jester lib answer. We will first look at this. So we're gonna do git clone lib answer. Whenever I've been doing C++ in this sessions, I've been using CMake, not because I'm very fond of it or whatever. It's just like it works for me as much as I need it, and I think that's the main point about all like source build systems. If it works well enough, why should I change it? Okay, so and CMake is meant to be used like this. We're gonna make a build directory. Build. Come on, give me some typing. Build CMake where the files are, and then run make. Okay, I fucked it up again, of course. This happens when you develop on one system and stream on another system. I think we will hopefully sort this out real soon. Robert, did you take the time? 7 minutes until my very first fail. I think that's a new record. Okay, here we go. So you can already see the package builds a library. It builds a binary that actually uses the library, and it builds a test for it. There could be a number of tests, obviously, but as this is a really simple thing, there's just one test, and the tests the answer. Okay, we can now like use the binary, see what it does. We can ask, because lib answer gives answers, and in order to get an answer, we have to ask. So ask, and the answer is 42. Works for me. And CMake has built-in support for running test sessions. So if I go like make test, it runs the tests. But what are the tests actually? The tests are, now hopefully I get this right. There is a directory called test, and yeah, where is the we're in the build. Okay, test, and the test is actually just like this. It uses the doctest testing framework and links against the lib answer. The tests, is the answer correct? And the call signature of answer is to return an int. And if the int returns 42, we are happy, then the test is passed. Okay, sounds sensible. And we got to look at the test definition for a second. Essentially, that's it. Executable answer test, link, and that's it. Okay, so really no magic hidden here. So we have understood we are producing an answer test binary that is being automatically run by make test, but we can also do this ourselves by running answer test. And that now we don't get the output by make test, by the magic that CMake generated, but now we get the real output of the doctest binary that we generated. Why is this different? Tests can pass, fail, and how do they return their outcome. One obvious way is returning 0 for all is good, and another obvious way would be like returning a magic string that says no way for a fail. The CMake test suite, as well as most other test suites that I personally know, return 0 for success and 1 for or something other than 0 for a fail. And this is also what this does. Okay. I'm not gonna jump through the fail and repeat and show cycle. You can do this for yourselves. Okay, now we do have a package that builds a test. The package, or we have a source package that builds a test. Now we need to make it a Yocto package. What do we need for a package? We need a layer to actually like put it into. And I gotta get rid of this. We don't need it anymore. That was just for demonstration purposes. And okay, we are gonna create a layer, bit bake layers, create layer. And as you all know, my layers are usually named after some form of metal. And when I look at ptest, the closest thing that hit my mind was plutonium, but plutonium is way too cool of a layer name to waste it for this topic, especially as badly prepared as I am. So we're gonna go for platinum. So this layer should be called platinum, and we're gonna add layer meta platinum. Okay, not that bad. What's the next thing we gotta do? We gotta create a recipe for the package. We're gonna use DevTool for this. DevTool add. I don't think we even need to give it anything other than just the source file, source path. Let's see what happens. Doesn't look too bad, does it? Let's just have a look. DevTool, edit, recipe, libanswer. Okay, you can see this actually worked, but no signs of any form of test. This is like not so good. What do we have to do in order to make our builds test aware? Two things. We have to tell the distribution or the build by itself that we actually want to be ptest aware. Usually this goes into the distribution. In an optimal world, this goes into the distribution. Let's be fair there. Usually you would have like your distro config that you are building, and you would have a derived testing distro that turns on all the needed bits and pieces in order to make this work. This is a bit much for your standard application developer run-of-the-mill testing. So what we're gonna do is we're gonna look at local.conf, and here it is. Distro features append space ptest. This means ptest is injected into the distro features, and every package can check for it. If ptest is there, then it should produce if the package can produce a test suite, then it should check for this flag and produce it if that flag is set. That's the way it's meant. Then a couple of you might have stumbled over another flag to set, which is like let me see here. There is the extra image feature ptest packages, which basically like slams in every ptest package into the build. But that's a little bit too much for what we are gonna do today. So I'm gonna show you something else. Okay, so our build is meant to do tests. So it's only the recipe that needs to learn it. I'm gonna go into the workspace here, so I can easily switch like terminals, because it will be a little bit cumbersome otherwise. Okay, so what do we have to do? We have to do to inherit ptest. It sounds a little bit logic, don't you agree? And what else do we have to do? Okay, I obviously like failed my notices, so I have to Google for it quickly, because I prepared this like yesterday evening and I was tired, and as usual I'm just badly prepared. Okay, so building ptest is the default on with Pocky. Might be Robert. Feel free to check. I don't know. Okay, what do we have to do? We inherit ptest, and once we have ptest enabled, we just need to tell it or add our actual tests. In this case, it means we provide a do install function for ptest, and it goes like this. Okay, hopefully I get this right now. These are executables, and they come from our build. I showed you they are in the test subdirectory, and we're gonna just like glob here for anything that ends in test. And we install into destination, and there into the ptest path, which is specifically set for each and every package, because ptest packages are like located next to each other under userlib. Okay, so if we got this right, then we can bake libanswer, hopefully. Obviously we can't, because, and that's why I meant we cannot. I should keep two editors open at the same time. But bake libanswer. Hopefully this all runs through. Doesn't look that bad. We're gonna, okay. So in order to get this into the image, in order to get this into the image in a sensible way, we gotta do the one true thing. We gotta create a specific image for this. So another terminal, YP live test, meta platinum, and mkdir recipes platinum, recipes platinum, mkdir images, cd images, and we're gonna just like do the classic start of core image minimal. If I manage to get it, is this actually right now? Oh, I think so. Meta recipes core images, core image minimal bb, platinum image bb. Okay, I forgot to mention, as usual, I'll happily take any remarks, insults, wedding offers, questions, also including answers, hopefully, and whatever during the session. Just like interrupt me in the chat or in Yocto now on Libera chat, as Freenode has kind of declined. Just like shoot me whatever you want. I love being interactive. You can tell me or ask me whatever. The worst thing that can happen is that I'll say either I don't know, in which case nothing is lost, or that I will answer later after some other process has been finished. So just like if you have something to add, just like go ahead. There's no like etiquette just like in a classic conference session where you have to say, can I please talk or whatever. Just drop it into the chat. Robert says that it's too late. That depends on your legislation. I think there are legislations in which it is not too late. So here, platinum image, and we want to install libanswer ptest. We're gonna be nice guys. We add to the description. It allows to boot and test libanswer. Ptest, does ptest work with Python packages? You mean you want to test a Python package? I don't see any reason why it should not work. We will get to this in a second. So, does this work? Bitbake platinum image? For the record, we're building for QEMU ARM 64 just for no good reason other than not wanting to build for x86. Manuel, actually, it's a good question, because I had a small discretion on the what a build, what a test returns and in which way, and we will get to that in just a small second, okay? And then you will understand why I think it should perfectly work for any kind of programming language, given the presumption that you actually can get everything that is needed into the build. That means it might be complicated to actually package it up. Maybe. Not necessarily, but it might be complicated. But that's a problem of the language and its ecosystem maybe, and not of ptest, because ptest will be able to run and use it. I'll show you in a second how. So run QEMU, no graphic, slurp. So much talking and already half an hour in. This is just like water for a couple of more minutes. Okay. I told you the tests are to be installed under user lib whatever. So we're gonna look at this. cd user lib and libanswer. Here is ptest, doesn't look that bad, and here is answer test. It works. We can run the test session, right? But as you can see, this is the doc test. This is the test suite of the of the source package itself. This is important as ptest. When you want to do automated testing, you don't want to script each and every test case of your packages. What you want to do is you have an image that you fire up and you start like tests, and then you go for a beer, and then you come back and you say good or bad, and that's the use case for ptest-runner. And ptest-runner has a list thing that tells me that no ptests are found. Can you guess why? I'll give you 10 seconds in which I'll find me a beer, and then I'll tell you. For the record, we're having a Weinstephaner today. No guesses? Anybody? Okay, so I gotta answer myself. The reason is the ptest-runner. Nope, the test. You're close, but just let that little bit off. I've proven that the package is there because the test is also there. So that means the test package is also in the image. But ptest-runner needs a specific entry point into the test suite of a package. And feel free to look up the documentation. I'm gonna drop the link in a second. It is so no, that was not good. Second fail. Robert, you're taking notes, are you? Okay. Now I've got a probably super cramped. Build directory here. No, it looks good. Okay. It's here. wiki.yoctoproject.org/wiki/ptest. Okay. So, and the ptest-runner that we've been using needs a specific entry point. That means the ptest package has to bring along a specific executable in a specific place. And this runner even has to follow a specific return value syntax. That's why I was talking about it so much earlier, because the ptest-runner does require it to return a simple an output string that goes like result : space pass, skip, or fail. That's the point of it. And therefore we have to edit. We gotta go for our recipe again. And where's the SUS URI? Okay, here it is. And we got a add file. And now I gotta cheat again because I have to look it up. It's called run, wrong window, obviously. run-ptest. That's how the file is supposed to be called. And we're gonna look it up real soon. We're gonna create the files directory. Then run ptest. And it means to look, it is meant to look like this. Or something close enough. So you can see it essentially, it goes into the user lib package ptest directory also, and it just globs over everything that's called like blah 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 underscore test, executes it, and if it's okay, then it goes like pass or fail, and then we're all happy. Okay, save. One small thing, we should rename the directory. That was a bad old practice that I just like stuck to. Okay, now everything is in place. Bitbake Platinum image again. Just have a small look at my mobile because it gave me some funny vibrations. Because we're packaging it at the moment anyways. Time for mobiles and drinking. Okay. And boot again. Here we are. Root. Okay. Let's hope for the best. ptest-runner list. Hey, lib answer is there. And ptest-runner. Mission accomplished. So that's it basically. That's what I wanted to do. What else could we do? We can like wrap it up by finalizing the recipe, which is actually a good practice. Okay, that again was stupid. Power off. Forays into DevTool. Hooray. DevTool help or whatever. Not deploy, not finish. Let's see what happens. DevTool finish. Recipe name and destination. Okay, I think we can get this. Finish recipe name destination. Does this also mean a partial path into a layer? Okay, I think we can get this. Finish lib answer. Meta platinum recipes platinum. The layer will go on GitHub sometime this weekend. Directory matching. Better now. Doesn't look that bad. DevTool status. Nothing in the build. Okay. So we're gonna be like crazy and look at Meta Platinum even. Recipes Platinum. Lib answer. And it failed. DevTool failed because it didn't bring along the run ptest script. I've seen the question. I'll be there in a second. So what do we actually need? Levancer, workspace, that's where the recipes. Oh. Now that was fun. DevTool finish just like got rid of my test script. No, that was not nice. Okay, we have to actually like build it again. And where are we? We are like meta, and we gotta get rid of the recipes example. So recipes platinum, lib answer, ls mkdir lib answer, cd lib answer, then run ptest, and drop it in again. Yes, no, okay, that was not good. That's it. Okay. Okay, this looks good. Bitbake, platinum image, and run qemu, no graphic slurp. Okay, now, what I prefer is a service manager for embedded devices. It all depends. It's actually like Yocto Project number 2, I think, but it really depends on what one wants to do. Because sometimes you need just like fire up the image, do 1 or 2 really simple scripts, and then that's it. And your space constrained. Then you obviously go for some kind of sys5 init, maybe even the one in BusyBox, which is really, really small, and it does what it's supposed to do, which is good. On the other hand, there are situations where you actually do something more complicated, where you want proper restart features, watching features, you want to react on devices being plugged in and out, or you maybe even want an integrated network managing thing. So then you probably go for systemd. I personally like systemd for journal-D and for network-D. So if I take into account the things that I would have to manually add to a System 5 boot in order to get the same functionality that I want and systemd already brings along, then I personally go for systemd in most cases of production images. Whereas in an updater image or a rescue image where you just, or a manufacturing image that just like has to boot up, start one application that checks the device, you don't necessarily need everything of this. So it's not a preparation. It's a decision based on requirements, and a decision based on requirements should be what you do for everything in your images, and not just on personal preferences. Robert's question: is this master latest? Almost latest, I think, from Tuesday. With question: will Linux ever replace Windows? It depends again. You know, it depends on what the use case is. And Robert has a very good point there. It's the other way around. Systemd does not work with muscle, so it's all again of the it depends and requirements. If you require some specific feature or capability of muscle, maybe its licensing model or its size or whatever, then this is a requirement. And if your feature requirement goes for systemd, then those requirements have to weight against each other. One will win probably. Then you either have to decide for muscle and slap everything on by hand, or you have to decide for systemd and live with glibc. That's how it works. I think it's not a I like or a preference decision. It's a look at your requirements decision. Okay. Next remark I'm gonna skip because I am not into opinions just for the sake of opinions. Can I show the recipe again? I can. And good point. There is something weird going on here. I don't think that this works. We're gonna, okay. Note to myself, whenever I gonna use DevTool in a live coding session, I have to be up for strange results. Okay, login rod also doesn't work. Because I expect now just like I'll be back for the recipe in a second. Okay, no ptests run, no ptests found, but the libanswer ptest, but the thing is there. Yep. Okay. Power off. And we're gonna look at this in a second once I've kicked off the next build. Okay. So did I have to add the run ptest script manually? No, I did not. I think this is a very good remark. So I avoided it until now. So you are joining me for the real first time, where we actually look at the ptest class. Where are we? No. Pocky, no. Where are we? Okay, we are still in the layer. Pocky, meta, classes, package, ptest class. Okay, and I probably guess run ptest. Here it is. Here is the do install ptest magic that checks if some file called run ptest is in the working directory of the recipe, which we have put it into by adding it to the socio-URI, and then it installs it just where it is actually being needed. That's the magic why I didn't have to edit manually. Okay, ptest-runner again, list and ptest-runner liban. So okay, everything works again. So the layer is basically ready to be run in or to be pushed to GitHub. Okay, I'm gonna look at it. I'll put it on the screen so you can see it. So that's all the payload. There is nothing more to it. Okay, let me look at the next question. It's rather long by bipolar transistor. Yocto produced binaries on the host. Yeah, well, it's always a trade-off. It's a trade-off on how much infrastructure you need for the tests or do not need for the tests. Once you want to test against real drivers, then it's like complicated because the drivers obviously have to be there. And I think the classic approach would be to test in layers. So have unit tests for everything that is above the layer, which can be fast and just like a native build, and and some more involved tests that go for the drivers that are then being run in a real QEMU. Having said that, I am also not a really strong believer in running all tests in a Yocto dev flow, because, as you already say, it's like slow, and the round trip is very very long. So I personally would probably do it in a staged approach. I would have really small and fast test suites that are not run through Yocto, but through the mechanics of whatever development environment I use. Like on VS Code, for example, you can trigger stuff on just saving files, for example, and then the test kicks off. That's like stage one. And only if that stuff actually like passes, then you go the next stage where you push to a Git repository where the more involved tests are being run. And if you have a proper CI/CD pipeline in place, then after a passed unit test run on the build host, it goes into an image production, and that image is then being run through a test image, in that case actually, on your build infrastructure. And so you can like stack test suites up from smallest and fastest to be run often, and most involved and slowest to be run only if you have already enough confidence in the code to actually justify spending the time and cycles there. I think that is the best answer I can give without really knowing the specific use case and application testing strategy. It really depends a bit. It depends on the language. It depends on the ecosystem a bit. It depends on the libraries you want to use. You need to use. So this is really something that doesn't have a really best practice. If you look at the approaches for different build systems alone, then how many build systems are there? And now you have a plethora of ways to run tests, and this is basically a combinatorial explosion. So I personally like doctest because it fits the way I do my C++ testing, but other projects, other infrastructures, it's hard to give proper advice, in my opinion. Okay, I'm gonna have a peek into IRC. IRC was awfully quiet during the whole session, for no idea why. I've dropped the link to the documentation, and the obvious simplest way to get started with this is looking at a recipe that already does what you wanted to do, which is also what I did. The layer index has a way to look for images that inherit a specific class, and I just like open up the layer index and looked for image recipes that inherited ptest. I picked LevelDB because it's super trivial and it also uses CMake, so I basically just like did a small rip-off here. I think that's the real pro tip for anything that's about creating recipes. Look at other recipes that already do what you want them to do. Okay, ideas for next session. Other questions? Still no wedding offers? Because I hopefully will be back in August. So back to the monthly schedule. As usual, follow me on Twitch. Follow me. I'm the Yocto Jester on Twitter. Also, don't forget to follow the Yocto Project, of course. And with that, I think we're done for today. And I have a nice slide that I need to scale. Like I said, I'm badly prepared. Okay. Thanks for watching. See you in a month. I'll put everything on GitHub. And I wanted to say something. The show notes will be on the yoctochester.info sometime through the weekend, hopefully. Oh, well, and well done. Drop me a remark. Whatever. Take care.